Hello and welcome to Course 3 Advanced Lessons in CodeJumper. This is Lesson 12 about variables. In this lesson, students will be able to understand what a variable is and be able to develop programs that use a variable. The expected outcomes are that all students will be able to explain that a variable is used to store a value for use later in a program. Most students will be able to use variables to play the same sound at different points in a program, and some students will be able to use variables to control multiple loop selections. And as always, we have our key vocabulary. And we have two words today, and that's variable and constant. A variable is a placeholder for a piece of information that can change. A good example of this is algebra. We have a problem that has 3x. X is that variable. To put 5 in that, that's 3 times 5 equals 15. So a variable is found across the board, and we'll see that in our unplugged and in our guided and exploration activities. Constant. We've seen constants before, and that's a fixed value in a program. Those are our purple plugs that we use that have the numbers on them. All right, we have our first unplugged activity. So the objective of this is to start to understand what a variable is and how it can be used in computer programming. And what we're going to be doing is using index cards and 2 boxes to put our index cards in. And in just a second, we'll look at what that means. Okay, so I have a statement and it says, tomorrow I'm going to, parentheses, place, close parentheses, and I need to bring, open parentheses, object, close parentheses, with me. So tomorrow I'm going to blank, and I need to bring blank with me. So we need to fill in these blanks. So these are our variables, and in this instance, it's place and object. So on our cards, you ask the students to write down a place, and on the second card, to write down an object. So on the screen, I have a box with 5 different places in it. I have school, Disneyland, the park, the swimming pool, the moon. Those are all places that have gone into this box. They can be written on the card in print. They can be brailled, whatever format the student needs. And then our second box has those objects. And we have spoon, sparkles, my dog, sock monkey, a pencil. So then we can have a student go and pull out a card for a place, and then pull out a card for the object and fill in those variables in the statement. Tomorrow I am going to the park and I need to bring a pencil with me. Or tomorrow I'm going to school and I need to bring my dog with me. They don't always need to make sense, but they fit that variable. And feel free to change the sentence to one that actually fits well with your classroom. It can be really fun also if you don't give them the statement first and you just have them write down those variables, put them in the box, and then you end up with a Mad Libs kind of activity that can get pretty silly, which is a lot of fun. All right, moving along to our guided activity. This one, we're going to be creating a very simple program where the focus is on the variables, not the complexity of the program. On screen, I have a table with the header row of CodeJumper setup, play pod 1 sound, play pod 2 sound, play pod 3 sound. So students will be making observations about the sounds and writing them down based on the different variables and changes we make to the program. The first one is on the left of our left column is we have an original program, a program with X variable, a program with X variable with constant blank inserted into pod 1, excuse me, and a program with just a constant. Okay, so what does this look like? Let's jump over to CodeJumper itself and take a look. Okay, so in thread 3, I have Cowboy Country. I have 3 play pods connected to a hub, just in thread 3, with the sound set as Cowboy Country. I'm just going to go ahead and play this program. So we had the saloon doors, we had a horse galloping, and then we had a horse neighing. Great. Okay. So now if we were to put a variable in there, things are going to change a little bit. So what I have sitting next to the program is actually a piece of styrofoam, another one of my hacks. That's about 2 inches wide, about 10 inches long. And I just poked holes in it to put all of the variables and all of the constants into it. So it's nice and organized and neat. So I have the variable, and it's a bigger gray plug, and on the top has a port in it. So I'm going to insert this into the sound dial of the first PlayPod. Now my app says play X for 0.5 times speed instead of what it was before, which was the saloon door. So now we have this variable. Remember, a variable, we have to assign a value to it. It has to have a value there. So right now there's no value. But if I were to put in one of the constants in the top, then we get our value. So now we have X equals 4, that X equals 4. So going back to that algebra analogy, the value now of X is 4. So when I press play, okay, so now that changed that value. Okay, but what if we want to hear that sound in another spot? Remember, it's important to know that a variable, wherever it is in a program, wherever it is in a math problem, that variable is always going to be the same if it's the same variable. So you have X anywhere in an algebra problem, it's always going to have that same value. So I'm going to take another one of these gray variable plugs, and I'm going to insert it into the sound dial of PlayPod 3. I'm going to press play and see. Let's see what happens. And swinging door. Same thing. So now we have that swinging door sound in PlayPod 1 and 3 because that variable says wherever you see this gray variable plug, you're going to hear the same sound. So for our students, they can just play around and see, well, what happens if I move this variable plug to the second PlayPod? So go through and fill out this chart and give the kids time to really engage and think about what that actually looks like. Okay, so in this lesson, we actually have multiple guided activities because this is a more foreign concept of variables that a lot of these students haven't been introduced to. So we wanted to give a lot of opportunity for exploration. So I'm going to change out my program. And what we have on the screen right now is a picture of the program. It is 2 loops, one in thread 1, one in thread 2. And each of these loops has 3 PlayPods. So I'm going to change my camera so we can see what's happening on screen. All right. Okay, camera's back up. So all I have right now on screen is my hub. So I'm going to use my hack where I use my cutting board and I bring my whole program right up under the camera. So it's already put together. I don't have to worry about messing up. So I'm going to go ahead and plug my program into threads 1 and 2 into the hub. Okay, we heard those clicks. So now we know that our program is running. I'm just going to run the code really quick so you can hear what program.
Thread 1 people sounds. Loop 2 times. Play surprise. For 1 times speed. Play sneeze for 1 times speed. Play blowing nose for 1 times speed. And loop. And thread. Thread 2 tools. Loop 3 times. Play sawing wood for 1.5 times speed. Play sawing metal for 1 times speed. Play clock ticking for 1 times speed. And loop. And thread.
All right, so we have this program with these 2 loops. And if I was to press play, we have our thread 1 that says loop 2 times. We have our thread 2 that loops 3 times. So they're not the same. So using variables, we want to make sure that these loop the same number of times around without turning the dial. So I'm going to use my variable, and I'm going to go ahead and put that into this dial of the loop pod. It doesn't matter which one. So now it says loop X times. And I'm going to put the second variable, we have 3 variable plugs, into the other loop pod dial. Now the loop says loop X times as well in thread 2. But we need to give it that constant. We need to give it that value. So I'm just going to go ahead, for time's sake, I'm just going to put in loop 2 times. So I inserted the 2 constant into the variable plug inside of the loop pod. So I'm just going to press play and let's see what we got.
Surprise! Surprise!
All right. Okay, so now we have our program. It went around twice because we had our variable number 2 in there. That sounded kind of like a shop party right there, and there was a lot of building happening. So the point of this is not to build a program that is necessarily a story or anything. The point is to have these things running together simultaneously with the same number of loops around. So we put in 2. We can have the students put in a whole bunch of different ones, but
X equals 2. X equals 2.
There we go. I will take that one out. And the next part is inserting the random plug. So again, that's our plug that's purple with an R on it. And I'm going to insert that into the variable plug. And now it's a random number of times playing. So every time you press play, it'll go around some random number between 1 and 8 number of times. So it's really making that idea more concrete of that constant, or in this case, that random, tells both of these loops to go around the same number of times. And then this program, I did notice I needed to debug, and this is important, is that we have our sound, same number. That's the speed is the same, so you can kind of you can hear how many times it's going around, so it's not kind of off. Other option is to put a pause in after your last play pod. That'll work too. Okay, going back to our PowerPoint, from that program, there is a little table that you can have different number of trials. So going random once, you press play, how many loops did it go around? Second trial, how many loops did it go around? Third time. So get that idea that variable with the random plug can change, or putting in a constant, then that's just set number of times. So that's our guided activity for this activity. Okay, so what we're going to look at next is our exploration. So in this exploration, students will create a program with a designated outcome using the variable plug. So really, what we've done so far is just kind of random things, what we need to do. But this one, we want a specific outcome. So the sound set doesn't matter, and choosing other sound set with 2 play pods inside of a loop. Each time the program loops, it should choose a note at random and play it twice. The loop should be set to repeat 6 times. So, or sound, it can be a note or it can be a sound. And so that's one of these. So I have actually created this program. So what we're trying to do is look at these programs and seeing where we can get them to overlap. Okay, so I'm going to change out my program. Again, going back to the magic of television, and I'm going to throw my correct program up on the screen. So I'm going to switch this out. One cutting board for another. So I just put that on this table, and then I'm going to take my hub from the other program and put these into, I'm going to use slots 3 and 4. And sometimes it takes a few minutes for it to readjust after having one program taken out and another one put in there. So I'm going to let it sit for a second. There we go. Okay, making sure our programs are all set up. And this one, it looks like I have to debug on thread 2. We have thread 2. Something is not connected quite right inside of my loop. And I'll try again. There we go. Okay, so I'm going to change my sound sets to MIDI instrument to piano. And then I'm going to change my second one to be here we go, row your boat. So remember with this, we want a specific outcome. So this one is going to be row your boat and a background of piano. So I'm going to press play and see if I can make that happen. Let's see if we need to debug. So listen closely to see if you can hear the rhythm behind.
Row, row, row your boat.
Oh, great. That worked. So I know I needed to loop it 3 times. And so we wanted to follow along. Row, row, row your boat. So this is where a variable comes in really handy, where you can put this variable into the loop pods and press play and see if that works. See if that's the right, oops, I need to put 3 in. Well, we tried 3. I'm going to put the 4 into the constant into my variable.
Row, 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 row your boat.
It worked, but that's not how the song actually works. So we need to go 3 and make that work. Let's see if it's 3.
Row your boat.
Oh, that didn't work. So that wasn't the right one. So we just keep trying and to see how we can get it to work. What is the right value for that? So there's a lot of options in the exploration to really dive in and create these programs to make a specific thing happen. Okay, so the second option is students will create a program that generates a random note and plays the same note on both a piano and violin at the same time. So the program should play 8 notes. So I'm going to show you the solutions to these. So this is where it gets really challenging for students, is trying to figure out and solve these problems. So we have thread 1, piano, loop 8 times, x equals random, play x for 1 beat, and loop. So there's a loop in there with a random number of times playing the same sound for 1 beat. Because remember, the variable, no matter where you put it in the program, doesn't matter if it's in the loop, doesn't matter if it's in the in a play pod, it's all going to have the same value. So you can go through and explore and try to solve these problems. So that's what we have for lesson 12 for CodeJumper. Look forward to seeing you next time. Thanks.